This is a video from section 3.6. Recall. Number 1, natural log of a times b is equal to natural log of a plus natural log of b. Number 2, natural log of a over b is equal to natural log of a minus the natural log of b. Number 3, natural log of a to the n is equal to n times the natural log of a. Note, natural log of a plus b is not the same as natural log of a plus the natural log of b. Now, the directions say to use logarithmic differentiation to find the derivative of each function. And with that, we're going to take a look at problem number 45. Suppose y equals x squared plus 2 to the second times x to the fourth plus 4 to the fourth. Now, we want dy dx, and so what I'm going to do is take the natural log of both sides. So natural log of y is equal to natural log of x squared plus 2 to the second times x to the fourth plus 4 to the fourth. Now, recall that the derivative of natural log of x is the same as 1 over x. We're going to need that in a minute. Now, natural log of y is natural log of x squared plus 2 to the second plus natural log of x to the fourth plus 4 to the fourth. Okay? And so natural log of y is the same as 2 natural log of x squared plus 2 plus 4 times the natural log of x to the fourth plus 4. So I'm applying the log properties right now. And now we're ready to differentiate both sides. And so this is a great application of the chain rule. Now, 1 over y dy dx is equal to 2 times 1 over x squared plus 2 times the derivative of the inside function with respect to x, which in this case is 2x. And then I'm going to add 4 times 1 over x to the fourth plus 4 times the derivative of the inside function with respect to x, which in this case is 4x cubed. And so this says 1 over y dy dx is equal to 4x over x squared plus 2 plus 16x cubed over x to the fourth plus 4. And so multiplying both sides by y, we get dy dx is y times 4x over x squared plus 2 plus 16x cubed divided by x to the fourth plus 4. But remember that y is equal to x squared plus 2 to the second times x to the fourth plus 4 to the fourth. So dy dx is x squared plus 2 to the second times x to the fourth plus 4 to the fourth. So notice we had to replace y with that expression, and we're going to multiply this by 4x over x squared plus 2 plus 16x cubed over x to the fourth plus 4. And we're going to leave it right there, and that's problem number 45. If we take a look at 47, So here y equals the square root of x minus 1 divided by x to the fourth plus 1. And we're going to take the natural log of both sides. So natural log of y is the same as natural log of the square root of x minus 1 over x to the fourth plus 1. But this says natural log of y is 1/2 natural log of x minus 1 divided by x to the fourth plus 1. But the argument inside the natural log is a quotient, and so we're going to split it off accordingly. So natural log of y is equal to 1/2 of natural log of x minus 1 minus natural log of x to the fourth plus 1. Okay. And now we're set up to take the derivative. So 1 over y dy dx is 1/2 the quantity. And we're going to get, now, the derivative of natural log of x minus 1 with respect to x is 1 over x minus 1. So I'm going to put 1 over x minus 1. The derivative of natural log of x to the fourth plus 1 with respect to x, applying the chain rule, is 1 over x to the fourth plus 1 times 4x cubed. Now I'm going to multiply both sides by y. So dy dx is y over 2 times 1 over x minus 1 minus 4x cubed divided by x to the fourth plus 1. And then all I have to do is put back what y is. So dy dx is 1/2 multiplied by the square root of x minus 1 divided by x to the fourth plus 1 times the quantity 1 over x minus 1 minus 4x cubed divided by x to the fourth plus 1. And so just kind of remember y over 2 is the same as 1/2 y. Those two mean the same thing. And that's how I get from the second line down to the third line. That's 47. If we take a look at 51, suppose y equals x to the sine x. And we're going to take the natural log of both sides. So natural log of y is the same as natural log of x to the sine x. Now I need to move the sine x out in front of the natural log. So natural log of y is sine x times natural log of x. And now I'm perfectly set up for taking the derivative. So 1 over y dy dx is the same as. Now I'm going to write the first function, which is sine x. I'm going to multiply by the derivative of the second function with respect to x, which is 1 over x. And then I'm going to add natural log of x times the derivative of the first function with respect to x, which is cosine of x. Now, dy dx, I'm multiplying both sides by y, so that's y times the quantity. Sine x over x plus cosine x times natural log of x. Let's double check. Yep. And then I'm going to replace y with x to the sine x. So dy dx is x to the sine x times sine x over x plus cosine x times natural log of x. And that's 51. 53. Suppose y equals cosine x to the x. And I'm going to take the natural log of both sides. So natural log of y is the same as natural log of cosine x to the x. And I'm going to move the x out in front of the natural log. So natural log of y is x times natural log of cosine of x. And now I'm ready for the derivative. So 1 over y dy dx. So again, I'm differentiating both sides with respect to x the whole time. Now, that's the left side. 1 over y dy dx is x times the derivative of natural log of cosine x with respect to x. So you get 1 over cosine x times negative sine x. That's chain rule. Plus natural log of cosine x times the derivative of x with respect to x is just 1. So dy dx is y times the quantity, negative x tangent x plus natural log of cosine x. But remember that y is cosine x to the x. So dy dx is cosine x to the x times the quantity, negative x tangent x plus, and then I believe it's natural log of cosine x. So let me write that down. And there we go. That's problem number 53. Let's take a look at 55. They're all very similar in concept. Take the natural log of both sides, use properties, sometimes one property, sometimes multiple properties of logs to simplify the side that contains x's, and then differentiate both sides with respect to x. Same idea the whole time. So y equals x raised to the natural log of x. Natural log of y is the same as natural log of x to the natural log of x. Move the natural log of x out in front. So natural log of y is natural log of x times natural log of x. But I can write this as natural log of y is natural log of x raised to the second. Now I'm ready to differentiate both sides with respect to x. So 1 over y dy dx is the same as, I'm going to apply the chain rule on the right-hand side as well. So I get 2 natural log of x times 1 over x. So dy dx is 2y natural log of x divided by x. But y is x to the natural log of x. So dy dx is x to the natural log of x times 2 natural log of x divided by x. And that's 55. And that'll do it for this video. For section 3.6, we worked on problems 45, 47, 51, 53, and 55. Thank you.